the speaker to begin. Thank you.
Thank you for the great introduction, ma'am. Good evening, everybody. Today we are talking about, or we will be discussing about artificial intelligence and its application in soil and water management. Mm, so, coming to myself Ashok Kumar. I'm working as an assistant professor at GPS Institute of Agriculture Management, Bengaluru. We were working with many peoples and many allied peoples, and we are gathering information related to this AI application in soil and water management. And our institute comes under Karnataka Agrochemicals Multiplex Group of companies. So, and we are having one UTIX, uh, the AI powered center, which we are providing a farmer solutions with using that based upon the soil and water management aspects. So today's topic is widely we will be discussing on that aspect only. So first I'll go with uh, the beautiful thing, which is nothing but then agriculture. Agriculture is a major thing which happens in India as well as in the world. But in India, it is a culture for all the peoples, those who can provide and those who can apply it in a scientific way as well as a cultural way. So, agriculture as a part of our culture, agree is a major thing. So, we were facing many things after our independence. So it was termed, and we were evaluating or evaluating from that sector. So in this case, we'll be having, and it has been notified that from 19th century to till now, we are having O's, which means 1.0, 2.0, 3.0, 4.0, like that. We have classified our agriculture sector in a way. So why it is classified like this means earlier days it was practiced only with the traditional aspect, which means traditionally how we are utilizing our resources which is available with us. Then in mid 19th century we faced an industrial revolution. So then we are having a computerized revolution or computing revolution. Now it is a smart revolution. So in agriculture 1.0, it is called as traditional agriculture. 2.0, which is called as mechanized agriculture. 3.0, it is called as automated agriculture. Now we are at the fourth stage, 4.0, which is called as smart agriculture. What is the major difference or key difference between these things means? Earlier days in 1.0, we mostly used to have, or mostly we are not mechanized that much. So manpower and animal power, which is the most common thing which is being used, and they are much more not as much as expectation, as well as the skill is also an big drawback there. Then we have been evaluated or evaluated, or what we can say, we moved into the industrial part or industrial revolution. So here comes the mechanization. Slowly we have started moving from animals to the machineries. So even though we are moving in from animals to machineries, most of the illiterate part of the farmers are not able to afford the machineries and they can't utilize in their field. So this is the big drawback in 2.0. Now we are moving into we are in the semi-automated phase of 3.0 and 4.0. We are not jumped continue. We are not fully jumped into 4.0, or we are not fully following 3.0 also. So what we are doing here, we are on the 3.0 and we are evaluating the 3.0 into the 4.0 part. So 3.0 is just nothing but after mechanization is done, we are doing that machines to do their work automatically by providing various informations or various data. So which helps us in further movement of next sector of agriculture. Then nowadays, now we are aware about we are in the smart phase or else digital phase. Everywhere we can see all the sort of things, all informations, all the regulations, or everything we are converted, or we are being converted, or we are also being converted into smart peoples. So now there is a drawback in the agriculture. So that is why we are shifting that smart things into agriculture also. So these are all the major things which is happening in the agriculture. So while coming to the 4.0, so in 4.0 we are having versatile things in the sense we are focusing on all sort of sectors, not only agriculture, along with their allied sectors also we are focusing. Not only focusing on chemical manufacturing, we are also prescribing the chemicals and also how much it has to be used and how much it has to be applied. That aspect which is given to the machines in a smart way. So this can be done by this sort of things earlier. In 3.0, it is done by the means of models. Models means for a set of data which will be given as an input and it will be processed and output will be derived by that particular thing, particular model. So in smart agriculture, it is not like that. It is variety of data and implementing or providing varieties of data into the model and they will provide us the output with a manner. With a manner means we are not interfering in the data aspect. So it will prescribe the output as per its thinking. So that is why it is called as artificial intelligence. So they are having their own intelligence on predicting and analyzing and giving the output. So that is what the integration of IoT, AI, and big data. So while coming to the smart farming or smart agriculture, so big data which we are providing is being sorted out or easily solved by the smart farm models. So this is about the evolution. Next thing is the content of this particular presentation or discussion topic. So first is what are all the things which are included in agriculture along with AI. Second part will be dealing with how soil is being interpolated or being combined with AI. Next is how we are combining water with AI. The last one is most important thing. The agriculture 4.0 is mostly focused on this concern only. So to prevent ecology as well as environment in the sense of sustainable agriculture things. So how we can achieve these or all the things? Uh, how we can achieve the sustainable agriculture thing with using AI? This is what the thing. First, we are moving into the AI. AI in agriculture, which is being categorized by two forms. One is the thing, the most important thing is technology along with the precision farm. The second one is machine intelligence along with the agriculture. So machine intelligence agriculture is a 4.0 and agricultural technology and precision farming is a way back 3.0 which is providing the basic data for 4.2. So here what we are majorly focusing on means so the things which is we are focusing on is we are converting the agriculture from normal thing to digital farm or digital agriculture. Everything is converted or everything is being converted or everything will be converted, whatever the thing. So we can take it. So it is converted into a digital form of agriculture. So or else digital agriculture. Then now how the digital agriculture is being processed? Only by the means of or a set of data. Data is nothing but either the informations which is provided by us as a backup thing or a non-spatial thing or a spatial thing, spatial data that they can collect from a features with using specific technologies. Specific technologies in the sense, while coming to the precision farming or precision agriculture, precisely we are going to predict as well as we are going to suggest and as well as we are going to give everything precisely. So that is why it is called as precise farm. So here the data intensification is being promoted or else increased or availability is being enhanced by the means of the sensors as well as the GPS, GIS. These are all the sources. Then after combining all this information collected from the sensors as well as geographic positioning system as well as geographic information system, these are all called as inputs. These inputs are being processed with the models and then that will be given as an output. So that technology is being developed with the software. So that software is, they will calculate what we need to do with the available data. So the output will be based upon the input which we have given. So the precise application of, if it is, for example, I'm giving a soil analysis data, or else earlier pest infestation in a particular crop. For example, if it is a rice means I'm giving um, any one of the major pests. So I'm giving the incidence that as an input data, and that will progress, and that gives you output. What sort of pesticide you need to spray, how much amount of fertilizer you need to apply. That is called as VRT technology, variable rate technology. Variable rate technology, which familiarized word, which is ruling nowadays everywhere. Variable technology, which means, so even we are applying fertilizer, that will be monitored by all set of informations which is provided as an input, and the output is also being properly monitored. So then coming to the machine learning agriculture. In machine learning agriculture, so what we are doing, AI driven missions. AI driven missions means, so AI driven missions here, what are all the things means, we can see nowadays most of the AI driven missions which we are using as uh, now in our mobile. So we are having variety of AI driven missions. Many things, auto suggestions will happen. So for example, Alexa or else Google Assistant. So they are AI driven missions. So here coming to the agricultural part, what it will be, how it will be function or how it will be done is, here it is easy while coming to the human approach. Human approach means we can easily give command to the Alexa or else Google Assistant to give us the feedback. While coming to the agriculture, it is not that much easy to handle. Here we are focusing on the neural networks. In neural network, artificial neural networks are plays a vital role here. In there is variety of neural networks are available. While coming to the agriculture, we are focusing on CNNs only. So conventional neural network. Conventional neural network is nothing but why we need to go for that particular neural network means. For example, if I am having an information about a rice crop in the sense rice, how much it will grow, how much height it will grow, what is the physiological appearance, what are how the leaf structure will be there, shape of the particular plant, size, everything. So these are all the conventional things. Otherwise, in technical term, in machine learning, it is called as features. Features or features of that particular any objects which we are taking. So what ANN will do or CNN will do, they will extract the information about the particular features and they will keep it. Then they will provide the precise information accordingly. So here you can see the ANN function. So you can visibly see that, so it starts from land preparation till the harvest. So what we are telling, so here the land monitoring analysis. So land monitoring analysis means all the lands are not even in a way. So they are having undulations everywhere in wherever the farmer is doing the cultivation. So based upon that, how much slope is there, what sort of crop I need to cultivate, how much the soil is having nutrient content. So that and all the initial thing which I need to analyze or I need to give or I need to get as an data. Then it will be processed. After that, I need to select a crop. Crop selection is the most important thing. Which sort of crop I need to choose and whether I go for a single sole crop or multiple crop or intercrop, like that I need to do. Then how much amount of irrigation I need to give. So it has to be based upon the prediction of soil moisture as well as the weather forecast. Coming to the nutrient management, how much amount of nutrient which I need to give. So after the soil testing data is updated, then this will be recommended automatically. Next, coming to the health monitoring, either the pesticide or any animals or anything intrusion, everything is being properly monitored. Then it is yield management. So you can see the arrow marks here. So they are having equal distributions or vice versa. So one is interrelated with another. So here all these five major processes are interrelated with one another. When I am analyzing the data and I am feeding it into any one of the uh, any as an input, then it will gives me the crop. And then this thing, so water management is done by the means of sensors. So sensors, we are having variety of sensors. In variety of sensors, weather forecasting sensors are there, soil moisture prediction sensors are there, temperature sensors are there, humidity sensors are there, everything is there. So with using that, we can predict for up to 15 days of weather forecast. With that, we can, when we need to give water, when the crop is in need of water, at what stage we need to give water. So these and all will be done by the means of PPD or packaging practices of any crop. Everywhere we can see from land preparation to harvest for a crop, we'll be having a basic information. That basic information will provide a basic data for processing ANNS. So artificial neural network will be processed. For example, coming to the rice again. So a rice is being grown in a puddle field. So how I need to maintain a water column? How much amount of water column has to be maintained at a nursery level? After transplanting, how many times I need to give irrigation? Whether it is based upon the soil type or whether it is based upon anything, any factors. So that is the thing. Next season, next what sort of things I need to follow. After that, how much nutrient I need to give at earlier stage. At after transplanting, what are all the nutrient I need to give. These are all the basic informations which is already fed into the thing. What it will do, ANN, it is like our neuron. It will process and it will gives us the output. So then we can go with that particular outputs and then we can minimize the cost of input and the farmer can increase their benefit cost ratio. After that, if he is having versatile resources means he can or this thing is also suggesting after harvesting what are all the post harvest mechanization or post harvest management he has to take. For example, after harvesting of his rice crop, he needs to dry. After drying, when he needs to take that particular produces into the market, when the viability of that market is getting increased, when the demand of the particular produce is getting increased, if it is an storageable uh, produces, if it is an perishable produces, if we are having alternate things. Okay, so then these are all the major processes by AI. So then, most important thing now, AI is driven by this four major sector only. Our 4.0 is also majorly focused on four things. One is most important thing, the valuable resources water. How we are managing the water and how we are giving the irrigation and how irrigation is being done. Then second one is managing the crop as well as the soil. So properly we need to monitor the soil as well as the crop. If it is not properly monitored, problem will be arise in different. So then detection of the pest which is prominent in that particular crop, either it may be a major pest or minor pest. Then based upon that, whether I need to go for IPM, integrated pest management, or whether I go for any sort of pesticide application. That. So now 4.0 is majorly focused on this thing for variety of crops in a variety of way. Okay. Next is apart from agriculture, many other allied sectors also in. So, for example, for monitoring cattle or poultry or piggery farm or sheep or goat, anything. So, we are having many applications or many things being introduced nowadays. How it is being introduced? Sensors, cameras along with sensors with monitoring the either any sort of livestock. So that is the major key role here. That is the one sort of. Next is another most important thing or most important problem while coming to the field. Field level, weeds. Weeds are the most important problem. And nowadays we are having weed specific pesticide application with using GPS. If it is a GPS or global positioning system. Okay. So while coming to this thing, so weeds or otherwise called as whatever it may be. So none other than the particular crop which you are sowing, everything is called as weed. For example, rice. In rice field, if any other crop, any groundnut or anything is growing means also that is also considered as weed. While coming to the weeds species also, there is leaf, sorry, broadleaf weeds, sedges, like this variety of weeds. Based upon this, the sensors has been developed. If it is a sedge for controlling sedge, the weedicide is being applied. It will not be applied for broadleaf sort of thing. So that is based upon the machine learning, and that isn't being identified by the computer vision or by the means of machine learning through the means of crop nature. So shape, size, everything is being about that information is being collected, and that is being distinguished in a way. How it is being varied from crops that we are going to identify, and we are managing it, and the harvesting part. While coming to the harvesting part, sorting and grading is the most important problem. Then we are packing it as a A1, A, B, C, like this we are doing grading. Grading is also being done. How we can do this thing? For example, if it is a tomato crop, tomato means optimum size this much. This much size we can put it in a grade. So there is a level being fixed in a that particular software. So they are being programmed in the software, and they will quickly what they will do, they will sort it out, or they will separate them into a different sort of produces. In a same produces, different sorted things will be done. Next is the most important thing, surveillance. So a farmer can't surveillance his own 10 acre of land. So the surveillance has to be done with using AI application, which will be helpful for him in managing all sort of things. If he is having not only having agricultural crops as well as allied sectors like livestock, anything. So if he is having, means he has to be monitored with using AI. So this is about the AI. So how the software is being functioned. So you can see many deep learning things are in the websites. So you can go and refer in that particular website. So AI, while coming to the AI, so if it is a crop, then the sensor will identify the things. It will be sent to a perfect platform. Then that particular thing is converted into a data. Then AI, artificial intelligence, will take a decision what sort of implement I need to use, how much acute things has to be done, for which crop it has to be done. Everything has to be done in the software only. The software is being programmed in a proper way. So next, first part is over. While coming to the major thing, soil. So in soil, there is four things. While coming to AI, first thing is mapping, second is monitoring, third is remediation, and fourth is optimizing. Mapping is nothing but we are doing two sort of mapping. So in mapping, so variety of things we can do. So variety of things means so we are having sorry geostatistical models and machine learning models. Mostly, the geostatistical model will provide the basic data for processing the machine learning models. So here comes for mapping. Mapping means soil mapping is nothing but we'll be taking one theme. So like physical properties of soil or chemical properties of soil, anything we are taking and we are mapping the soil. Then what we are doing, so this is done by geostatistical model. Individual property is done and they are combined with the overlay, map overlay will be done. Okay, either geostatistical model, what they will do, combination of raster data and vector data, and they will develop the map. Then the map is being combined as a output by the geostat. Then that particular huge resources or huge data being taken and it is put up in this model, and it will be further processed. So this one is done separately as well as this one also separately done. This one helps in doing machine learning. So while coming to the machine learning, we are having place to place or time to time differences. Temporal means we are having time to time interval. Spatial changes place to place interval. For example, if I'm cultivating a rice crop for short duration crop, 3 months crop it is. I am doing for it that particular crop. After that, if I am doing for next crop means next I am going for next season crop with a different thing. So geostatistical model will give different data, which means I am going for pulse crop. It will give or it will sense and it will give different data. This has to be processed very well in that manner also. So they are done in a series of time also. In a series of time means the software is being built in that way. So they can process different types of crops at a particular time. So here comes the mapping. So while coming to this thing, so here we are having different types of depths, 10 centimeter, 30, 50. So here you can see percentage of organic carbon content. Here 0 and here 6. So most of the topsoil, which is brown in nature, so they are having more amount of organic carbon in the soil compared to the subsoils, 50 centimeter. Here coming to the moisture. Moisture is also it varies depends upon the places. Okay, and also top layer will have which is having 35 percentage of moisture. So this is the thing. Next is what are all the mapping techniques which we are using? Topographic maps, drones which is used where humans can't go and access the things. Drones can be used and satellite image. It is common nowadays. Satellite imageries. So geospatial things. So next GIS, Geographic Information System. This is the database for everything. So earlier data, current data, we can use it and we can process it and we can give it for further. Then coming to the photogrammetry, which gives you topographic map, this sort of cadastral map, these sort of maps are being done by the photogrammetry. Next is digital mapping. As I said that as we discussed that, so raster and vector data is done, and one map is overlaid on another map. Sorry. So on overlaying only we can get a good output. So these are all the mapping techniques which is being associated with AI and program. So this is the one of the major. Next is soil monitoring. Coming to the soil monitoring, we need to monitor the soil in a proper way. So which will be helps for the farmers or researchers to identify how much my soil is getting degraded, either by the means of pesticide application or by any means of sources. So which will provide what if I'm giving the impact of the soil which is being degraded, which can be provide you the real time solution by the soil monitoring protocols. Okay. Then coming to the remediation, my soil is being polluted by any sort of potential toxic element. So that is being identified and that is being restored by the means of either by phytoremediation or microorganism using bioremediation, or else I can use biodrainage with using crops, anything I can do. So that will be suggested by AI. What sort of toxic element is present in that particular area and how we can design it. What either I can go for which sort of organic pollutant is there. Either it may be organophosphates or chlorines, organochlorines, any sort of thing. That impact I need to see whether it can be remediated by bioremediation or phytoremediation, anything that is being given and given or suggested by AI. This is the next is optimization is the most important. After remediating, proper optimization of soil should be done with using the decision support system. Decision support system is a basic key role playing here, which will gives you all the predictive analytics of the soil. So what has to be cultivated, how much yield it will be giving, what is the soil quality, everything it will be given by this optimization process. Next, after the soil, they are focusing on the water. So water is having separate AI model also, and it is being interpreted with the soil as well as thing also. So here coming to the soil water management aspect. So first foremost thing is climate. After climate, water quality. If water is having problem, if my water is having higher amount of hardness, that is a problem. Higher acidity, that is also a problem. Then my field monitoring has to be properly done. Whether my field is having undulations or elevations or topography is not being done. These are all the things, the scheduling of irrigation, then crop growth monitoring and soil monitoring. These things can be done by the means of sensors. So later I will explain one demo also. We are having one application and then I will show you how the sensors are working. Okay, sorry. So this AI is being done mostly by different types of irrigation methods. So sprinkler, center point or drip irrigation. Most commonly used thing is drip irrigation in India. So this rest of the things are used in abroad countries. While why drip irrigation and micro irrigation is being promising in India means most of our farmers are small farmers or marginal level farmers. Their lands are limited, so that is why they they are utilizing these sources. So the drip along with AI is a more useful thing. So AI means how much amount of water it has to given in a particular day. After that, after how many days gap I need to take. So it is common for all this method. So now in India, this is the most prominent and promising. So then data driven by management of water. So what we are doing in India, we are not managing water properly. Not only I'm blaming on water. So everything, every resources which we are having in abundant, we are not utilizing it properly. If we are utilizing the natural resources properly, means it will be conserved properly and it will be given to the future generations. So here comes the thing. So what we are doing, either we are overwatering the field or else if we are not watering it properly. A proper humidity and moisture level has to be maintained and right amount of water we need to give for proper yield of the crop. So this thing processing by a farmer and applying it into the field, it is a time consuming process. AI will give you the easy solution with using GI based weather sensors and as well as soil sensors, everything. So and also remote sensing. So this will be combined with model satellite images and weather parameters or weather prediction data, and it will give you the crop specific irrigation system. If it is a rice, how much amount of water I need to supply till the end from starting to end. If it is a vegetable crops, how much amount of water I need to give. What is the irrigation schedule? How much time gap I need to give? Which type of soil? If it is a red soil, how much gap I need to give? If it is a sandy soil nearby oceanic areas, how much amount of water I need to give? These are all the calamities which we need to see and we need to go. So this can't be done by the farmer manually. So when you are providing the data related to that particular problems, the AI will process and it will provide you the solution. That is by the means of sensor-based irrigation. Sensor-based irrigation is nothing but it is done by the means of soil-based sensor or plant-based sensor. Two things. So we need to focus mostly on both the things. If we are focusing on soil-based sensor means only it will cause problem also. Okay, real time solution is done by the means of this predicted irrigation, followed by plant-based sensor. If my plant is grown to some extent, how much amount of water it needs. If it is in a child or smaller stage, how much amount it is in need of water. If it is in nearby harvest stage or reproductive stage, how much amount of water I need to give. These are all the things I need to calculate. If it is an agricultural crop, this is no problem. While coming to the vegetable crops, we are picking it regularly or we are harvesting the crop in a regular interval. Then we need to go for proper irrigation management. So the sensors which is manufactured and given, they can identify even a small shrinking and swelling of the soil. So they can send the alert messages to the particular farmer. So you can see here a sensor is being placed in a soil. So you can see the video. So this is an underground sensor. So this sensor, what it will give the information or data. So this will be transferred to the particular decision software. That software will gives you when the irrigation has to be carried out. So this is how the functioning or tailored irrigation or irrigation scheduling is being done. So the sensors which is present nearby the root zone will identify how much amount of moisture is present in that particular soil area. So you can identify and that will take a decision and that will process and that will give you the irrigation. Next, most important thing is malfunction. Malfunction or anything which is happening in the irrigation pathway. So either it may be cut down or salt may be developed or anything, leaks, any intervention by rodents or anything. That has to be identified or it can be identified easily by the sensors. When over leakage of water is there, the limited amount, for example, if a drip irrigation is there, in a particular hole, this much amount of water need to be comes out. There is a thing which can be programmed in the sensor. If over water is flowing in that particular area, the alert will be given to the farmer through many interconnected devices. So if a farmer is having, as we discussed, more amount of land means that will be a problem for him to identify that particular thing by manually. So if it is an AI, it will be easy for you. And also irrigation sensor will provide you and it will be useful to tackle the water related solutions. If it is in scarcity or else wastage of an water that is most prominent in agriculture. They are creating problem in the production aspect of all sort of crops. So we need to be intelligent and in the way how we are consuming the water in agriculture aspect. So these are all the different types of drip irrigation: inline, standard, adjustable. Most prominently, adjustable type is being suitable for AI-driven things. Okay. So monitoring and control system. While coming to that monitoring aspect, sensors is being used, proper technology is being combined. Most benefits are there and cost effective also. So last and wind up session is there. So this is nothing but sustainable agriculture. Why we need to focus on sustainable agriculture? All the producers which we are consuming, which is being admixture or being uh, mixed with the pesticides, which is given by non non available awareness among the pesticide application or anything. So if we are giving over usage of things, so we are lagging in the sustainability. So that is why we need to have an information management cycle. So in this case, so risk management is the most important thing. That is why, so not only in farming process, it is directly involved in all living organisms. If we are excessively applying anything, so it will be moving into the human biology as well as livestock biology. For example, if I'm applying excess amount of fertilizer or excess amount of pesticide on a rice crop, the straw which is fed or eaten by any one of the livestock, that will be mixed in the livestock's life cycle. Again, the producers which comes out from that livestock, again it is being utilized by the human beings. And the harvester producers also is being the major thing. And here coming to the risk management, proper predictive analysis has to be done for errors. Errors in the sense, here farming error they are telling, it is linked with all sort of errors. Next, coming to the plant breeding aspect, proper crops has to be breeded and it has to be advised in a proper way how it has to be cultivated according to the weather, disease, and what are all the harmful pests which will be coming. If some seasonal pest is there, we should avoid some sort of crop. If the weather is, if a crop is not cannot be withstand the weather, we should shift to the crop or resistant crop which we need to, which we can grow easily without affecting the yield. Next, coming to the most important aspect, so soil and health analysis. This gives you the amount of fertilizers you need to apply and amount of nutrient which is present in the soil and how the crop health is being monitored. If soil is not having enough amount of nutrient, the plant will not establish good in a good way. So they are lagging of nutrients. So that will invite the pest. Inviting the pest, what they will do if they are good in health condition, the plant can withstand the problem which is caused by either a disease or any other insect. If they are not having enough amount of nutrients, they are having problem in the sense, and that can't withstand. So that is the thing. So here AI will solve you that thing. So next is crop feeding and harvest. While coming to this thing, crop feeding, enough amount of optimal nutrient pattern as well as nutrient applications has to be done in that way. So then harvesting of the crops. So good harvesting can be done and the processing has to be done in using AI is being done by this proper management of the information. So last, optimization of resources. How we can optimize the resources with using AI. We are having big data. It has to be processed with the real-time information. Next, IoTs. Proper information, Internet of Things with using sensor has to be given and it has to be, so that thing has been monitored with using a training data. Next, intelligent automation. Whatever the thing which we are doing and we are feeding it as a data, they will reduce the errors on the risk management, providing the basis for risk management. Next, robotics for all sort of major things. So then we are having four major challenges. One is upfront cost. So all farmers, all small and marginal farmers can't buy this sort of and afford this sort of AI. Then second thing is government has to take few protocols and steps or regulations to manage this thing on helping the farmers by providing a motivation and resources and training related AI. Next, most important is technology limitations. All the technologies can't be given to the farmers easily because time taking time taking process will happen. So this is the another thing. Last one is issue on security. So vast data we are collecting. Data is related everything. Every data, everything as a data. So the data can be easily taken. So by anybody. So legal questions will be asked. So everywhere where when a technology is introduced, that technology is having pros as well as cons. So mostly most people are focused on the negative aspects or limitations. Now we are on agriculture. So as an agriculture people, we need to focus on positive things and we need to overcome with the negative or limitations also. So the limitations will be overcome by the AI thing and good agriculture will be practiced because our GDP is being supported mostly by agriculture sector only. So with this, I will finalize my thing. So if you are having any doubts, you can post or I'll post the questions. And as I told you, I will show you one thing. So you can see this is our institute's uh, sensor. So we have installed weather station. It is done by our colleagues. They are UTIX or UTIX management. They are, comes under multiplex group of things. We have installed two soil sensors, so which will provide us the alert regarding to irrigation, plant care, soil health, weather forecast, everything. So, for example, if it is an irrigation advisory, so here they have given many things. So here the red color is there. So wilting is happening. So it is suggesting that you need to give water for that particular crop. Then you can see empty box, no data. We have removed our soil sensors because we are there, we are preparing our field for next season of crop. So this sort of information which will be given already or it is programmed in the software and you can see how much percentage you need to apply, minimum, maximum, how much water you need to do. Here you can see soil type, depth of the sensor which is placed. We are having two sensors and field capacity, how much, field capacity maximum, how much, building point, everything we are having. Then coming to the plant care. If I am having any problem in the plant, I can take a picture and I can put it in this thing. And we will suggest you what we need to do, what is the problem, and you can message us. Next is soil health. So we can create. So whatever, if you are installing that thing, whatever the crop which you are going to do, description about the crop, you can see the series of nutrients. You can add one nutrient and their unit and their things. Then you can submit it. Then with this, what it will do, it will predict and it will suggest you. First, you need to do this soil health reports. So after giving this, that will provide you the result on the basis of what crop you need to do,
Sir,
how much.
sorry to interrupt, sir. You are
Yeah,
in the last slide. Are you sharing anything else, sir?
yeah, it is not sharing.
No,
Wait, my
no.
I'll share.
Stop sharing this one and then share them, sir.
Yeah, you can see now.
Yes, sir. Yes, sir. Now please
Yeah,
start, sir.
this is our UTIX, our company associate. So our farm is being installed with uh, weather forecasting sensors. So here you can see components like alerts. So the alert which will gives you all sort of increased things. All sort of increased things means if my for example, if I need to irrigate my field means you can see less, more, more moisture here, less moisture, wilting is going to happen here. The field is having wilting condition. Here we should irrigate the field, like that it is telling the soil sensor we need to irrigate it now. Then empty boxes are there, what it is telling, so we are remove that sensor for next crop. So it is showing that no data. So initial data is what type of soil, how much depth we have taken, what is the serial number of that instrument which we have installed. Everything, every basic information is given. So the irrigation advisory is being given here, and the plant care. While coming to the plant care, you can take photos and you can add this thing into the photo, sorry, in this application. And then what it will tell, so if, for example, any major pest or any diseases, it will be suggested automatically. While coming to the soil health, so I'm having my own data means I can feed it and what sort of crop I need, I can select it, and nutrients. So my pH is this much, EC is this much. Like that, I can feed the data and I can come up with the AI analysis. What it will give, it will suggest me, for example, if it is a soybean, so possible irrigation you need to do this time, and your soil is deficit with this sort of nutrient. For example, nitrogen, if it is less than 280 kg means you need to go for this type of fertilizer. And when you need to give, at what date you need to give, everything will be given by this thing. Next is weather forecast. So maximum temperature, minimum temperature, and rain. How much amount of rain it is there. Uh, so on 20th May, how much? So today, how much it is there. In our farm, it is around 5 millimeter rain is there. And it will be given up to 1 week. 1 week data you can have, predicted data. So temperature, humidity, everything you can see. So this is how an AI application will work. So this is a complete set of AI thing with weather forecast and soil health that will gives you irrigation advice as well as how much amount of fertilizer you need to apply, how much amount of all sort of things, how much you need to apply. Everything it will be given by the suggested things. So with this, I'm ending the session. So if you are having any doubts, you can ask. Thank you.
Okay. Thank you very much, sir, for a wonderful presentation. I will take up the questions now.
Yes, ma'am.
Since we are running short of time, I will quickly take up few questions, sir. Okay?
Sorry for the
That's
time.
okay, sir. How do current policies and regulations support or hinder the adoption of AI in soil and water management?
Oh, I can't get you. Policies?
Yeah, government policies.
Yeah. If, for example, our government is focused on any, uh, for example, ma'am, nowadays have been implemented soil health card scheme. So that data, with using that data, they can develop one software to the farmers and they can integrate that soil health data with that particular app, and then they can suggest the farmers that this much thing you need to apply for the soil for this season. And then they are having weather data. Every state is having their own weather data. With that thing, they can give or they can associate this both the things and they can suggest for a particular block or for a particular places or block level or for an state level they are commonly suggesting means it will go up as per the district level, so then that can be utilized properly. Am I giving you the correct answer, ma'am?
Yes, sir. Yes, sir. What role can government and international organizations play in promoting AI use in soil and water management?
Actually, ma'am, IPCC, so Interpanel for Climate Change, they are mostly focusing on solutions for all sort of agricultural problems. So that is a major international organization which is combining with FAO, and they are providing the solutions. And this is being internationally discussed, but it is not widely applied in our country. So that is the major problem. Why? Because of that, this thing is happening. So we are having problem in maintaining the resources, as well as we are having problem in accumulating with one another. We are diversified in everything. So if a policy comes there means we need to follow it. So for not only for soil and water management, it will be enhancing the sustainability in the environment. So sustainability environment will help us everything. So that is what the thing.
Okay. So what are the main challenges in deploying a solution for soil and water management?
Very nice question. Um, what we can do means problems we are facing in irrigation aspect. So water is not even sorry, water quality is not even everywhere. So they are having main problem. So somewhere fresh water is there, somewhere problem water is there. So that is the thing. And water is not being properly utilized. So this has to be connected with rain harvesting facilities and watershed management aspect. These are all the things which has to be linked. These are all having different sectors or different ministries or different departments. So these things has to be united and they can provide us the solutions. So they are separately giving us statistical data. With that data, we can't process or we can't give a solution in managing the water as well as in the soil. So we need to conserve the soil, and also it has to be done while combining the information from various resources. So we are lagging in the information of combining or over combining the one another's information. So that is the major problem here.
Okay. Can you provide examples of successful AI implementations in soil and water management? Any successful case studies are there, sir?
Yeah, many case studies are there, ma'am. Now I have showed you now, ma'am. So in our
Okay.
farm, we have done two different crops. One is we are optimizing the irrigation schedule for tomato crop, as well as our unit, our colleagues, they are doing optimization in India level, in grapes farming, everything, in everywhere in nearby northern states, most of the things are being done by this UTICs, and they are coming up with an irrigation schedule for grapes as well as many other crops like soybean, tomato, these sort of crops. First, they are focusing mainly on vegetable crops. They are focusing on perishable commodity. We have successed in some sort of things. In Kolar also, they have implemented many things and they have got success results also. Many case studies are available. I'm telling about our UTICS program. In India, there is variety of people who are doing AI. So they are having very good success in that.
Okay. What are the ethical considerations associated with using AI in soil and water management?
Yeah, ma'am. Ethical, we have the ethics while coming. AI will provide us the sustainability and precision in agriculture, which will limits in the application of or overuse of the fertilizers or pesticides. These things will be limited. So, which provides a basic idea about the AI.
Okay. Thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we like to thank Mr. Ashok Kumar M for the talk and for answering the question. This meeting will now be closed.
Thank you, ma'am. Thank you for
You're
the
most welcome, sir.
opportunity.